So let's get started. I am going to share my whiteboard. All right, so I have shared my whiteboard. You would be able to see that in some time. Okay, so let's talk about vectors. Okay, we'll start off by some basic concepts and then we'll talk about the complicated things as well, right? So let's say if you have been asked to find any vector, right? So honestly speaking, vectors are not difficult. You can always think about them as you locate any point on graph, right? But this time you have a 3D plane, okay? That is the only difference. That is it. So you should know the very basic thing that if you have a vector AB that is in the plane, it can be calculated by OB minus OA, where OB and OA are the position vectors of B and A, right? So did you know about this concept?
Yes.
Okay, very good. So OB and OA are position vectors. So basically now we know that when we talk about position vectors, it is basically the vector between OB and OA. Like position vector of any point is the vector between that point and the origin, right? Okay, this was basic. So let's just rub this and talk about the next thing that is very, very important from exam point of view as well. So let's talk about that. Okay, that is basically the vector equation of a line. Now, obviously, we have been dealing with equation of a line. That's not an issue, okay? But this time we're talking about vectors and we're talking about the vector equation of a line. So basically, let's talk about that line first. And then we will talk about three ways of representing that equation. And three of them are correct and they are equivalent, okay? So let's say that you have a line. Let's say this is your line, this pink line. And you have a point on it that is point A. So A point has the coordinates x1, y1 and z1, okay? This is the point A. Okay, other than this, you have been told that there's a vector which is parallel to this line. It is the yellow vector. It could be on this line as well, right? You should know this thing that if a vector is on the same line, that would also be parallel to it, okay? So this vector has the coordinates. This vector has the coordinates, yes. Um, A, B, and C. So this basically is AI plus BJ plus CK, right? Did you understand this?
Yes.
Okay. Now let's talk about the three methods of writing down the equation of this line. So I'll talk about first here, then second one here, and the third one here. Okay. So one way of writing this is basically the most general form where we write down vector equation. It is basically x, y, z equals x1, y1, and z1 plus t into a, b, c. Okay. Now, basically, you need to understand that this is basically your vector equation that is equal to the point lying on that line plus t multiplied by the vector that is parallel to your line. Now you can use T, S, lambda, mu, that is your choice. Okay, obviously it could be, it can be represented in any way. That's completely your choice. So we can also write it this way. R equals A plus TB. Okay, now this is obviously a simple version of writing it. And again, A has the coordinates x1, y1, z1. A is basically the point on the line, and B is a vector parallel to it. Okay. Now this is the first and the most used version of equation, vector equation of a line, and T is a constant, right? T is a constant. Okay. Let's talk about the second one. So the second way is basically this one. You can write it this way: x minus x1 divided by A equals y minus y1 divided by A equals z minus z1 divided by C, and this is B basically. Okay. Now again, what are ABC? ABC are the components of the vector that is parallel to that line, and x1, y1, and z1 are the coordinates of the point that is lying on that line. Okay. So this is also a way of representing the vector equation of a line. Anything that you have not understood so far?
Can you please repeat it again?
Okay. Okay. Let me write down the final one and then I'll explain this again. Okay. So the last one is parametric equation. And that is x equals x1 plus at, y equals y1 plus bt, and okay. Now, basically, we are talking about the vector equation of a line. Okay, so for now, just forget about the simple equation of a line. We're talking about vectors. So things would be different, right? You will come across questions in which you would have to find the vector equation of a line, and that line would have, let's say PQ or AB, stuff like that. Okay, for that, you just need two things. Okay, for finding the vector equation of any line, you need a point on that line which you will have to find. You will have to figure that out on your own. And the other thing is the vector parallel to your line. So we are finding out the vector equation of this pink line. For finding out the vector equation of this pink line, we need a point, that is A, and a vector that is parallel to this pink line. That vector is ABC. Okay. So you write it this way: x, y, z. It's just a way of writing it down. Equals x1 comma y1 comma z1. This is basically your point that is on the line plus t, that is a constant, and it is multiplied by ABC, that is the vector parallel to it. Okay, so in short, you will basically be seeing this in the marking schemes as well, because this is, a simple version of writing it down. But again, small a and small b are what? Don't get confused, please. Obviously, you might get confused because we have used small a and small b there as well. But you should know that this is basically the point on the line. This A is x1, y1, z1, and this B is the vector that is parallel to the line, right? Did you understand this?
Yes.
Very good. Okay. Similarly, this is one way of writing it down. This is the second way. Here again, x1, y1, and z1 are the coordinates of that point lying on your line. And A, B, C are the coordinates of the vector that is parallel to your line, right?
Yes.
And both of them are vector equations of a line. They are similar, okay? And the last one is parametric equation, which is 100% similar to the very first type. Just follow this. Just think about this, this, this. If I compare x, if I compare the first components of these three vectors, what do I have? X equals x1 plus at, right? X equals x1 plus at. This is the first one. Let's talk about the second one. Y equals y1 plus bt. Y equals y1 plus bt, and then the last one is z equals z1 plus ct, right? So basically these are the three types, but in the questions which we will be doing today, I will be using this type, right? To just focus on this. In short, just know if you have been asked to find out the vector equation of a line, you need to find two things: a point on that line and a vector parallel to that line. And yes, in marking scheme, you will find too many alternate methods because these are vectors. Your solution and your friend's solution could be different, but it could be that both of you are getting full marks, right? Because obviously the point could be this one or this one or this one. Any point that you can easily find, all of them would give you the correct answer, but the answer might be different, okay, but that would be correct. You will see that in marking scheme as well, okay? Okay. All right, so this was the concepts about vector equation of a line. Let's just do an example or two quickly, just so we are able to do the past paper questions as well. Okay, so let's say we have a line that is this one. Okay, let me just clear the screen. Okay, now the question says find the parametric, or I'll keep it simple, not parametric. Let's just do it this way, then we can do it from all these three methods. Find the equation for the line passing through the point 1, 2, and -3, and parallel to the vector A that has the components 4i plus 5j minus 7k. Okay, so this is the question. We have everything. This is why it is easy, and this is why the questions in past papers are difficult, because here we know the point and here we know the vector. There obviously they are not going to give you the point and vector directly. Okay? You need to find those, and then again you are good to go. Okay, so how do we find it? We have multiple ways. So can you tell me one way? Okay. Yes. Right. So if I talk about the coordinates of x1, the coordinates of point that lies on the plane, it is this one. So this means that x1, y1, and z1 equals 1, 2, and -3. Okay. And this is the vector that is parallel. So if I talk about the parametric equations, they are going to be x, y, and z. Then what do we have in parametric equations? We have x1 plus at. So it would be 4t, right? Because 4 is a, then b is 5, and then c is -7. Okay. Then y would be 2 because of this 2 plus 5t.
5t.
And what would be z?
-3 minus 7t.
Very good. Excellent. Okay. So this is how we talk about the equation of particularly the vector equation for a line, right? That is passing through this point and that is parallel to this point. So did you understand this?
Yes.
Okay. Now, if I talk about another example quickly, I'll just do it. All right. So let's say this time you have been asked to give the vector equation of the line in this form: r of t equals r naught plus tv, and you have been told that the point A is 9, -8 and 5. What is point A? The point on lying on the line, okay? And the vector parallel to that line is, let's say, S, and it is I plus 6j minus 1 by 3k. Okay, so this is what we know. All right, now it's very simple. R of t is going to be r naught, that is the point lying on the plane, that is this point. Now you can write it this way: 9 minus 8, 5 plus t into 1. Either you can write it this, yeah, okay, it could be I plus 6j minus 1 by 3k. Okay, so did you understand this? Also, you could have written it this way as well: 9i minus 8j plus 5k equals plus t into I plus 6j minus 1 by 3k. And this is the form, basically, this is the form of the vector equation of the straight line, which you will see that which examiner basically prefers. Okay. So did you understand this completely?
Yes.
Okay. Let's talk about the next topic quickly. So now we have the equation of a plane. So for that, we need to understand a few things. Okay. So again, we will talk about the general form and then we'll see what do we do in questions. So basically for equation of a plane, you need to understand one thing, that okay. So basically you should know that now again we can write it and we can do it through multiple ways. Okay, I'll write down the first type. So it could be that you have ax plus by plus cx plus d equals 0. Okay, it could be this one, or it could be that you have a point that is basically lying on the plane that has the coordinates x1, y1 and z1. Okay, and ABC is a vector perpendicular to the plane, so we can write this equation as well: a x minus x1 plus b y minus y1 plus c z minus z1, this is going to be z as well, equals 0. Okay, now basically we have these two ways of writing down the equation of a plane. This is 1 and this is 2 and they are linked. Okay, c is basically abc ai plus bj plus ck. This is basically the vector that is perpendicular to the plane. Okay, it is basically the vector that is perpendicular. Okay, now you should know that vector and points are interchangeable, right? At times we will be writing down vector as a point, and at times we will be using a point as a vector, because this is how we locate a vector, using the coordinates of the point, right? So you know that there's a connection between a point and a vector, right?
Yes.
Okay, so did you understand both of these types? Like this could be the first one and this could be the second one, okay? Then when we talk about the questions over there, we'll see when to use which type, right?
Okay, can you please explain this once again, this part?
Okay, all right. So what do we have? We have equation of plane. If I talk about the first one, we can write it as ax plus by plus cz plus d equals 0. Now, how to use this one? Okay, x, y, and z are basically fixed. A, B, C are the components of the vector or the point that is perpendicular to the plane. Okay. So let's say that you know this point and you know this point. You will use both these in this and find the value of d, right?
Yes.
Okay. Or otherwise, if you are not interested in doing it this way, that okay, first I will have to multiply, then I have to make d the subject and then rewrite as x, y, z, you can use this directly. A, B, C are the components of this vector or the point that is perpendicular to your plane. And what is x1, y1, and z1? It is the point lying on the plane. Okay, so you can use either one or two, both will give you the same answer. And this would basically be the equation of the plane, right?
Yes.
Okay, let's talk about an example quickly and then we will talk about other things. Okay, so let's say we have okay, let's say we have this question. Give the equation of the plane with normal vector 10i plus 8j plus 3k that contains the point 10, 5, 5. Okay. Now this is the question. Give the equation of the plane with normal vector this that contains the point this. Now we can use any of the equations. So let's do it. So we can talk about this one where we have a x minus x1 plus b. Then we have y minus y1, and then we have c, z minus z1 equals 0. So what are ABC? ABC are basically this, this,
10,
and
8,
this.
and 3.
Very good, okay. 10 x minus, what is x1? x1 is the x
1 is
coordinate of the point lying on the plane, okay.
10.
Very good. Then 8y minus
5.
plus 3z minus 5
5.
equals 0. Okay. Now it could be that in the question they tell you to leave the answer in this form. Okay. Otherwise, it's always advisable to just simplify this. 10 into x will give you 10x minus 100 plus 8y minus 40 plus 3z minus 15 equals 0. So 10x. So 10x plus 8y plus 3z minus 155 equals 0. Now, what is this form? This form is again the very first form which we talked about when we were talking about the equation of a plane. What is this? This is basically ax plus by plus zz plus d equals 0, right? Where d is minus 155 and abc are 10, 8, and 3, right?
Yes.
Okay. So did you understand this completely?
Yes, it's fine.
Okay, very good. All right. So let's talk about the next thing, which we will be using in questions as well. Okay. So first you need to know how to find angle between two vectors. Okay. So this is not the angle between two planes. This is just the angle between two vectors. Let's say this is a vector, this is another vector, this is B, this is A, this is theta. You have been asked to find theta. You can go about it this way. Cos theta equals A into dot product of A and B, and then divided by A mod into B mod, right? Now we know that A and B are basically A mod and B mod are basically the modulus of vectors. So how do we define A mod? Let's say A has the coefficients x, y, and z. So A mod would be under root x square plus y square plus z square, right? And how do we
Yes.
do dot product? You know that. Do you know how to take dot product?
Yes.
Okay, very good. So this is one way, and then we have a sine theta formula as well, where we take cross product. So that makes it very, very complicated. So let's not go about it that way. And this was basically the angle between two vectors, okay? Let's talk about angle between two planes. So you need to understand this concept first. If I talk about the angle between two planes, you should know this thing, that just imagine that you have two planes and they have a common vertex and you are interested in finding out the angle. You should know this thing, that their angle, the angle between those two planes would be same as the angle between their normals, okay? So you will just calculate the normal vectors of that plane, and then you can just find out the angle between those, right? And then that will give you the angle between the planes. Did you understand this?
Can you please repeat it?
All right. So for that, let me just try making the diagram. Let's say this is a plane, and then I have another plane that is something of this type. Just imagine that, no, but they don't look what I wanted them to look like. No, they are parallel. Okay, I'll try making that then. Okay, so we have a plane. Just think of a book. Just think of a book. Okay, let me just make that book then. So we have a plane, something of this type. Okay. Now, are you understanding this? That we have basically a book, and we are interested in finding out the angle between these two planes. That is this angle, right? This theta.
Yes.
Okay. Now, in order to find this angle, we cannot, do it this way directly, because planes are different and vectors are different. We use the concept that is correct 100%, that if you make two normal lines coming out from both the planes, okay? So there would be a line that would be coming out from the above plane. It could be of this type. This thing, there is a normal line. That is, I would not be able to make it, but it is going inside the whiteboard, okay? And then there's a line coming outside this plane, and the angle between these two would basically be equal to the angle between these two planes, right? So obviously, don't think about these vectors which I made, because I would not be able to make them, because they are to be made in 3D space. But just imagine, open up your book and just use your markers or pencils if you have, and just imagine that you have two planes, just like the one I made. You have a book that is basically connected, where the point from where basically all the pages are coming out. You're interested in finding out the angle between the two ends of the book, basically. For that, you will find out the angle between the two normal lines coming out from both the planes, right? So just assume that the normal line coming out from this plane is n1, and the normal vector basically coming out from this one is n2. Okay, so you will get theta as cos theta equals again n1 dot n2 divided by the mod of n into n2, right? Just like this one, just like this example. Once we have the two vectors, we have to use this formula, and our two vectors are the normal vectors coming out from both the planes. Did you understand this now?
Yes.
Okay, and I will share a picture with you, or maybe I will just share it on the whiteboard. Just give me 1 second. You would be able to get a better understanding. All right, so I'll stop
Taylor
sharing.
product is also known as the dot product.
Which product?
Um, you said it's called dot product, right? So
Yeah,
isn't
yeah,
it
yeah.
called? It's the
Yeah.
same as scalar product, right?
Yes, yes, yes. It's basically when you're multiplying the x
Yeah.
component with x, y with y, and z with z. Okay.
Okay.
All right. So let me just show that like that. You see this as well. All right. So Ranjini, are you able to see the screen?
Yes.
Okay. Now just think about this plane 1 and plane 2. And are you able to see my cursor as well?
Yes.
Okay. So this is plane 1. This
No,
is
I'm not
plane.
able to see your
All right,
cursor.
but you can still see the planes and all that. Okay.
Yeah.
So we have two planes, and then n1 is the line coming out from plane 1, and 2 is the normal line or normal vector coming out from plane 2. The angle between these two is theta angle. Forget about that 90 thing and all that. Just understand that this is the concept, okay? That they are same, and this 90 and everything is telling you that why they are same, but we are not interested in that, okay? But this is why they are same. Okay, so this was about the angle between the vectors. Now I'll stop sharing this, and I think we can talk about the question now. All right, so for that, we need to open that first. And if I,
Okay.
so, all right.